Hello everyone, welcome back to my channel Kotfa and welcome to this tutorial of machine learning. And so today we are going to learn about the first algorithm of machine learning, which is called linear regression. Linear regression is a very simple but yet very powerful machine learning algorithm which is used to solve many regression problems. So let's deep dive into this algorithm today, and we will understand several topics of this linear regression, like what is linear regressions and what are its assumptions, how to measure the accuracy and the scores of this linear regression algorithm, and lots of more. So before starting the videos, guys, if you have not subscribed my channel, then please do subscribe it and please share and like my videos. So let's get started with the topics. So the first topic is, what is linear regression? Pardon me for my writing, it's not very good. So linear regression is a supervised machine learning algorithm. And if you don't know what is supervised and unsupervised machine learning algorithm, you can watch my previous playlist, that is Introduction to Machine Learning. I will provide the link in the description. You can watch it from here. I have explained in details about the supervised and unsupervised machine learning algorithm in very details with examples. So let's jump to this our topic, linear regression. So linear regression is a supervised machine learning algorithm which is used to predict which is used to draw a best fit line of curve using the dependent and independent variables. So now let's understand that what is this dependent? What is this dependent and what is this independent variables? So dependent variables, as you can understand by the word itself, the things which depend on some kinds of values or variables. Let me show you this with an example. So for explaining this linear regression, I am using my blog which I have written here. You can go to my website Code for Hub. There I have written the blog about the linear regression in details. Here you will get every information, including the introductions and types of linear regressions, and what is the examples, assumptions, and the performance matrices, everything. So let us understand this what is dependent and independent variables. So for explaining this concept, I have considered this table, which is a GRE score. Here in this table, I am predicting the chance of admission using these variables. So let's suppose that if you want to go into some kinds of university, and for that foreign university, you need to give a exam which is called GRE score. So my main aim is to find the chance of admission. So this chance of admission is our dependent variable, because this chance of admission depends upon the GRE score, CGPA, TOEFL, and university rating. So it is dependent on this all these variables. So this is called the dependent variables. And what are the independent variables? So the independent variables are this GRE score, CGPA, TOEFL, and universities, which is helping us to find out this our outcomes. So these are all are the independent variables, and the chance of admission is our dependent variables. Okay, and now I hope that you got a whole brief about the whole idea about the dependent and independent variables. Let's jump back to our linear regression algorithm. Let me erase this. So let's suppose that this is the usual diagram which you will find about the linear regression, and this is our data points which our model has predicted. Okay, this best fit of line is separating these data points. Okay, so this is called our best fit of line, and the equation of this linear regression is given by y is equal to mx plus c. So this is the equation of our linear regression, that is a straight line. You can also call it as the equation of a straight line. Let me write it very neat. mx plus c. So let me explain you what is this y, what is this m, x and c. So this y is nothing, it's our dependent variable, which I have already explained you what is dependent variable, because this is the result which I want to predict. So this is our dependent variable and this x is our independent variable. This is our independent variable. And this c is some concept value, some constant value. You can also call it as an intercept, and this m is our slope. Okay, so this was all about the equation about the our straight line. This is the independent variable, this is independent variable. This is the equation if you have only one variable, only one independent variable, and if you have a many independent variable, then you will write this equation like this: y is equal to m, and I have lots of equations, so m x1, variable x1, variable x2, variable x3, variable x3. Okay, so this is called multiple linear regression, where you have more than one variables and on the basis of which you want to predict your result, plus our intercept values. Okay, now let me erase this. So here you can see that this best fit line of curve, this best fit line of curve is separating our data models, and this is the points which our model has predicted, and this is the actual point. So there is a difference between this predicted values and actual values. Okay, so you can see that we call it as a sum of residual. This is this is the difference between the sum of residual. How you can define the sum of residual? The difference between the predicted values and the actual values. So, and taking the sum of all that. Okay. Now there's a concept called as cost function. So what is the formula of this cost function? So the cost function is given by y is equal to 1 upon 2m sigma, that is summation of y hat minus y whole square. This is the formula for our cost function. Now let me erase all this. Now let me consider this equation. Y is equal to mx plus c. Okay, now let's suppose that our c is the constant value is 0. Let me draw here the graph. Let me draw the graph. Okay, and let's suppose that our constant is 0, and this is our 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Now this c is our 0 and constant values are 0, and let's suppose that the slope I have considered here is 1. A slope value is 1, and let's suppose that our x variable is, I'm taking it also as 1. So what this equation will become? So y equal to 1, that is our slope, and variable x. So you will get your result as 1, and when your x values is 2, then what it will come? 1 into 2, that is m into x, it will become as 2. And when you will take x as 3, so your y value will become 3. Now let's find out the cost function. Okay, so what is our cost function here? Cost function is 1 upon 2m into sigma, that is summation of y hat minus y. Okay, so what is the value of our m? So I have taken m as 1, so 2 into 1, that is 2, and summation of all the values, that is y hat whole square, and that is x minus pardon me, this will be x. This will not y hat, this is x. So this will become as 1 upon 2 into what was the value of x? 1. 1 minus 1 whole square plus 1 minus 2 minus 2 whole square, 3 minus plus 3 minus 3 whole square, and this will become 0. This value will become, so our cost function is 0. So this is the graph between our cost function. You can also represent cost function as j of theta, and this is our slope value. So if I'm taking the slope as 1, I'm getting the cost function as 0. Okay, here 0. Similarly, if I will increase the m value, let's suppose that I'm taking m values as 1.5, so I will get some other values. So finally what our graph will look like, it will look like something like this. This is how your graph will look like, and this is called the global minima, and this whole concept is called gradient descent. This whole concept is called as gradient descent, which is another very huge topic and very important topic in itself. There is a huge explanation, there is a separate video for that will be coming in future videos. So for now, just know this is called as gradient descent problem. It plays a very important role. I will explain you in my future videos. So this was about the equation of the linear regression. Now let me erase it. So now let me come to my blog. So now here you can see that. Now let me explain once again this linear regression with the help of this blog. So here you can see that linear regression is a supervised machine learning algorithm. And this is the first algorithm which whenever you will going to start learn machine learning, you will begin with this linear regression. And here you can see that this diagram here. This is the best fit line of curve. This is the best fit line of curve, and this is separating the data points. This is another data point, this is another data point, and these are separated by this using this best fit of line. And this is the equation of your this straight line, y is equal to mx plus c. So let's see this definition. I have already explained this definition, but let me tell you once again. Linear regression is a supervised machine learning algorithm. It establishes the relationship between dependent variables y. I have already told you what is dependent variable, and independent variable x using this best fit line of curve. This is our best fit line of curve, and by using this curve, it is showing the relationship between our dependent and independent variables. Now let me move to this. I have explained about this equation y is equal to mx plus c. So let me explain you this with an example. So here again I am taking the example of this GRE score, that is predicting the chance of admission using this variance factor. So this is actually an example of multiple linear regression, because here we have multiple independent variables which are helping us to predict the chance of admission, that is our dependent variables. So this is our y, and these all are x1, this is our x1, x2, x3, and this is x4. Okay, so whether we will get the admission or not, this is depending on this GRE score. Whether you have good GRE score or not, what's your CGPA, TOEFL score, and what's your university rating. So by using all this variable, our model is predicting the final result. That is, what's the chances of your admission. Okay, so this was the example for this linear regression. And let's come to the assumptions now. What is the assumptions of linear regression? So the first assumption is there is a linearity between the dependent variable x and dependent variable y and independent variable x. So linearity means that is, the x and y are independent of each other. This is the assumption which linear regression model made while predicting its result. That is, if you are increasing the value of x, the value of y will also increase. This is called, means they are dependent on each other. The second point is homoscedasticity. So what is this homoscedasticity? So homoscedasticity means that the linear regression assumes that the variance of the model, the predicted result and actual results are same. They have same variance. And the third assumption is normality in data. That means the data is normally distributed. And what is the meaning of normally distributed? That means that when you plot your data, it will look like something this, a bell-shaped curve, shape, sorry. This is the bell-shaped curve which you will get whenever you will plot your data. That means the linear regression model is assuming that our data is normally distributed. And the fourth is observations are independent of each other. And you can, one more thing, it also considered as multicollinearity. That there is no multicollinearity in our data. So what is this multicollinearity? So this multicollinearity means the data are, that means the data are independent of, not independent, as there is no relationship between the variables of your data. If you will plot your heat map, the heat map is a method to find out the multicollinearity. So if any of the variables in your data has similarity, the main meanings of this multicollinearity, the two data have same features, like they are contributing exactly same, they have exactly same contribution to data. So if the properties of two variables having more than 90%, so these are called multicollinearity, because the two variables of your data are performing same. If you will find out it is more than 90% or 80%, you can simply drop that variable to avoid any multicollinearity. So your linear regression model assumes that there is no multicollinearity, which is actually not true, it's just assuming. So here is the measures of performance of linear regression model, which you can measure. This like mean square error, R squared, adjusted R squared. I will make a separate video on this performance method, because I don't want this video to be much more long. Let's keep it short because it's already become too long. So I will make a separate video on this performance measures. So now let's come to the advantage and disadvantage of this linear regression. So what is the first advantage? It performs very well with the linearly separable data. Okay, means that data are very linearly separated using this specific color line. Okay, and if this linear regression model is easy to train, and it can overcome. We can also there is one more point, that linear regression model can also be overfit. And underfit. Now, what it is overfit and underfit, I will explain you. I will make another video on it. So just know that for now that it can overcome this overfitting problem using L1 and L2 regularization. And also I will make a video on L1 and L2 regularization. So these are the things by which you can overcome the overfitting and underfitting problem. Now, what is the disadvantage of linear regression? So it is very sensitive to outliers. That means it can overfit. Okay, it's required a lot of feature scaling, and it can overfit, as I have already explained. And if there is a correlation between independent and dependent variable, then the performance model can be affected. So this was the disadvantage of linear regression. And what it is, outliers, everything I will explain. Again guys, if you want the links of this blog, I will give the link of this blog in the comments, in the description. You can access it from there, or also you can search on Google the code for how. You will get all my detailed explanation of this linear regression there only. So if I will show you, so just search here code for how, and this is what it looks like. And here you can access the machine learning playlist. I have also Python on the blogs about the data science. So when you will get to machine learning, so currently I have posted only 2 videos. I will be posting more, only 2 blogs. I will be posting more blogs in the future. So this is the introduction for the linear regression. You can watch it from there. So okay guys, this was all about linear regression. What is linear regression? So let me give a summary, a short summary about this. Then I will end up this video. So linear regression used to establish a relationship between independent variables using the specific line of curve. That is, the equation of this curve is given by y is equal to mx plus c. I have also explained you the example, and I have also explained about the advantages and disadvantages and what are the assumptions of linear regression. So okay guys, this was all about today's video, and in the next video I will explain you about the performance measures of linear regression, not regression. And by using the performance measure, you can check the score of your model, like how your model is performing. So then my next video will be about the same. So okay, this was all about today's video, and I will see you in the next video. And before leaving the videos, if you have not subscribed my channel, then please do subscribe it and please share and like my videos. Till then, I'll see you in the next video.